So far we've dealt with the naming system for alkanes, and we've learned how to deal with branches of alkane straight chains, and we've also dealt with cyclic alkanes and branches of those. So that's the system for the most part. Now we start applying the same system to different families of compounds. And so we're going to start with the alkenes and alkynes. And so you may remember from earlier, alkenes and alkynes have different bonding in the chain. And so the one thing to remind you of is this is now what we're dealing with. So branch prefix we dealt with, a prefix indicating a number of carbons, you should be familiar with. The suffix indicates the type of hydrocarbon bonding, and so alkene, alkyne is what we're looking at today. So that's different types of bonds within the carbon chains, and it can be straight chain or cyclic. Just a few more reminders. So the suffixes for the hydrocarbons in terms of bonding are ane, ene, and ine. So we already know what ane is. So the ene suffix, carbon-carbon double bond. Okay, so you got to remember that. A double bond is somewhere in the chain. Ine, Y-N-E, is a triple bond. And so instead of an alkane, you get an alkene or an alkyne. The other thing you have to do in addition to this with these particular hydrocarbons is you have to indicate the position in most instances of that bond, because that would represent an isomer. Different positions of the bond give you a different chemical structure. And so the position of the bond has to be indicated, and it has to be minimized within the longest chain. So that's definitely going to impact how you number carbons. And the other thing is, in terms of the order of things, the number appears before the suffix, ene or ine, indicating the position. So you're going to get things called one ene, one ine, for example. So let's have a look. Let's start doing some examples. So first one, propene, pretty straightforward. So here's now what we're looking at. The ene ending indicates it's carbon-carbon double bonding. That prefix, prop, is 3. So there's my 3 carbon compound, and it's a ene, so only a single bond, and so that double bond can be there, and then we'd saturate with hydrogen. Now remember, double bond changes how many hydrogen you can attach, and so there's the formula or condensed structural diagram for propene, and it has a formula CH2 CH3 structural formula. So propene. Now, we don't need a number here, because if you think about it, if I started numbering from here, 1, 2, 3, so that numbering indicates the double bond starts on carbon 1 to carbon 2. What if I started numbering from the other end? Well, if I started numbering from the other end, 1, 2, 3, I wouldn't have minimized the position of the bond. That would be 2 on carbon 2, or prop 2-ene, but that's not minimizing the position. So prop 1-ene would be a name, except it's always going to be on carbon 1 for a 3-carbon compound, so the number's not necessary. Okay, here's where we have to number. So but 1-ene tells us it's a 4-carbon chain, and the double bond starts on carbon 1 and goes to carbon 2. So we can draw that first. There's my 4 carbons. 1-ene, so 1. There's my double bond on carbon 1, because it could be on carbon 2, and if it was, it would be but 2-ene. And on carbon 2 there's a methyl group, so I'm going to put that there, and then I can saturate with hydrogens. Remember again, careful how many hydrogens you put on. Notice carbon 2 with the branch cannot bond any more hydrogens, and there's the rest of it for 2-methyl but 1-ene. 3-ethyl pent 1-ine. Okay, so again, pent 1-ine. There's 5 carbons. The triple bond, Y-N-E, is on carbon 1 to 2, and on carbon 3 I have an ethyl group. And there's my ethyl group. Whoops, 2 carbons, 2 hydrogens. No extra hydrogen on carbon 1, none on carbon 2. I can put a hydrogen here in carbon 3, 4, and 5. So 3-ethyl pent 1-ine. 2-ethyl cyclohex 1,4-diene. Wow, that seems like a mouthful, and it is, but the system tells us everything we need. first of all, it's a cyclic hydrocarbon, 6 carbon cyclic. So let's get our 6 carbons here. 1, 2, 3, 4, 5, 6. There's our cyclohexane, but it's a diene. So carbon 1. Let's call this carbon 1, and there's the double bond. So there's an ene. Carbon 1, 2, 3, 4. 4 to 5 is my other double bond. So that's the diene component, 2 double bonds. And then carbon 2, which is this carbon here, I have an ethyl group. Now I can saturate with hydrogens. Carbon 1 can take a single hydrogen. Carbon 2 has 4 bonds already, so it can't have any. Carbon 3 can take 2. Carbon 4 can take a single one. Carbon 5 can take a single one. And carbon 6 can take 2. And so there's 2 ethyl cyclohex 1,4 diene. So the system really works. So let's name these now. So again, the main thing is to get the numbering correct. And it's pretty obvious where I'm going to start numbering to minimize the position. I'm going to number from this end. There's my triple bond. That now takes precedence for numbering. And so that's going to be carbon 1. I have 1, 2, 3, 4, 5, 6, 7, 8. It's 8 carbon octyne. So it's going to be oct 1 ine. No branches, so that's it. But I must put that oct 1 ine. I have to indicate position because an isomer could be the triple bond on carbon 2, carbon 3, or carbon 4. Here's another one. And again, indicate position of the bond. Well, 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4, 5. So already you can see I'm going to start numbering this way to minimize the position of the bond. And so the triple bond is on carbon 3, and it's a 8 carbon compound, so it's oct 3 ine. So there is an isomer of the molecule above. That's why you have to position the bond and indicate it with a number, isomers. How about this one? So here's another cyclic hydrocarbon. And so minimize position of the bond and then minimize position of a branch. So there's a couple of ways I can number here. If I started numbering 1, 2, 3, 4, I'd have a branch on carbon 4, double bond carbon 1 to 2. Okay, so that's all right. But let's try a different numbering position. How about if I numbered 1, 2, 3, 4? So that still minimizes the bond, still on carbon 1. And the branch now is on carbon 3, so that's a better numbering system. And so on carbon 3 I have a methyl, so it's going to be 3 methyl cyclo, and it's a 4 carbon but 1 ene. So carbon 3 has a methyl branch. It's a cyclic with a double bond starting on carbon 1. Now here's a real crazy one, but again, minimize position of the bond. So that means we have to make this carbon 1, 2. Now we're looking for the longer branch. So 3, 4, 5. So that'd be 5 carbon. 4, 5, 6, 7. 7 carbon. 4, 5, 6. So 7 carbon. So our longest branch is this branch. It's a 7, and so it's a hept 1 ine. And on carbon, so we finish this off. On carbon 4 we have an ethyl branch, and on carbon 3 we have another ethyl branch. So we have diethyl. So what we have is 3, 4 diethyl hept 1 ine. 3, 4 diethyl hept 1 ine. Okay. Now another way to learn the systems is spot errors, and so this is a useful tool to try to figure out if the name's right or if the structure's incorrect. So let's look at this name, 2-methyl-3-ethyl hex 2-ene. So what's wrong with the name? Well, looking at it you can't tell, but if you draw it, so hex, there's my 6 carbon hex. On carbon 2 to 3 I have a double bond. Carbon 2 I have a methyl group. And in carbon 3 I have an ethyl group. And I can finish that off. That's H3, no hydrogens there, no hydrogen there, H2, H2, H3. So what's wrong with the name? Well, that looks good. And I drew a plausible structure. That structure is in fact correct. but this is maybe a little tricky. Eth comes before meth, so the order is incorrect of the branches. Everything else is fine, so that actually would be called 3-ethyl, 2-methyl, hex, 2-ene. Okay, so that is the correct answer. How about this one? 2,2-dimethyl-hept-6-ine. So we can draw that. 1, 2, 3, 4, 5, 6, 7. So there's my hept on carbon 1, 2. I have a, or sorry, on carbon 6. 1, 2, 3, 4, 5, 6. I have a triple bond. So there's my triple bond. And on carbon 2, I have a methyl group. And on carbon 2, I have another methyl group. So there's my plausible structure, and that structure is correct. There's nothing wrong with that structure. The name gave us the structure. It's just the name is not right, and here's why. Well, maybe you figured it out already. We minimize the bond first, so this becomes carbon 1, 2, 3, 4, 5, 6, 7. So the name, in fact, would be 6,6-dimethyl hept 1-ine. Minimize the bond position when you have a multiple bond. You must do that first. It dictates where the branches are going to lie. You never minimize branches if you have a double or triple bond. All right, how about this one? 3,4-diethyl pent 1-ene. 1, 2, 3, 4, 5. So there's my pent, 3,4-diethyl. So on carbon 3, I have an ethyl group. And on carbon 4, I have an ethyl group. Let's get the hydrogens in there to make it complete. Oh, I haven't put in my pent 1-ene, so there's my double bond. 1 hydrogen, 1 hydrogen, 1 hydrogen, 3 hydrogens, and so there is my molecule drawn from that name. Pent 1-ene, the bond position is minimized, but 1, 2, 3, 4, 5, 6. It's not a 5-carbon hydrocarbon, it's a 6-carbon chain. So there's my longest continuous chain. And so now I can renumber it, or rename it. So still a pent 1-ene, 1, 2, 3. On carbon 3 I have an ethyl group, and on carbon 4 I have a methyl group. So it's going to be 3-ethyl, 4-methyl, hex 1-ene. Okay, so again, a name is you almost always be able to draw something given the name. Sometimes the name's not correct. Last one, 3,3-dimethyl hex 2-ene. What's the problem with this one? Well, let's draw it. So dimethyl hex 2-ene. 1, 2, 3, 4, 5, 6. So there's dimethyl, or sorry, there's the hex. On the carbon 2, we have our double bond, and then on carbon 3 we have a methyl, and on carbon 3 we have another methyl, and hopefully you can already see the problem there. I'll just finish this off while you think about it. And so the problem is here on carbon 3. 1, 2, 3, 4, 5 bonds to that carbon 3, which is impossible. So that name is incorrect. You can draw it, and then you should be able to figure out why that's not correct. So again, what's the problem? The problem is C3 cannot form 5 covalent bonds. So there we go. That's the introduction to nomenclature of alkenes and alkynes. So alkenes with the double bond, alkynes with the triple bond. Other than that, the convention we've used pretty much apply, but now we do have to consider the position of the multiple bond, the double or triple bond, and we minimize that first. So that concludes this video.